Okay. Everyone taken down this problem in your notes? It says the closed system undergoes two processes, one after the other. Okay. Constant pressure process at a pressure of 5 bar from the volume 0.03 to 0.09. Okay. It is followed by a polytropic process. Expansion according to the law PV to the power of 1 point is equals to constant from 0.09 to zero point 0.2. Final volume. Sketch the process of PV diagram. Find the pressure of expansion. Work done during each processes. The network done 8 marks. This is the problem. Okay. So anyone like to try to draw a PV diagram looking at the statements? Just draw a PV diagram for this. All of you have taken this question in your notes, right?
No, sir.
No, sir.
Okay, take it down. Done?
Yes, sir.
Okay. So how does this PV diagram look like for this particular problem here?
Constant pressure process is given. So isobaric.
Yes. So first process is isobaric. Okay. That's great. So there is an isobaric process from state 1 to state 2. Okay. Has it given any sort of volume or any information
Yes, sir. Volume is given.
from? volume is given. Okay. Now, so let me draw the state table again. So for the state 1, state 2, and state 3. Okay. Now, pressures and volumes as of now. So, volume at state 1, any information regarding this?
0.03 meter cube.
So, it is 0.03 meter cube. Okay. So, 0.03 meter cube. Regarding this, volume at state 2.
0.09 meter cube.
0.09 meter cube. Any information regarding the pressure at which isobaric process happened?
5%. Get convert.
Okay, so 5 bar in the sense of 5 into 10 to the power of 5, correct? So both the pressures are same as this as isobaric process. Okay. Now, what else? Any other information? Next,
This
only how many processes are there, by the way?
polytropic expansion is also there.
Polytropic expansion is also there.
From state 2 to state 3.
From state 2 to state 3, there is a polytropic expansion. Okay, fine. So
State
it
3
will
volume is
reach
given.
state 3 volume is given. How much?
0.2 meter cube.
0.2 meter cube. Okay, so this is a polytropic. So polytropic expansion in the sense any um, index is given.
K is equal to 1.3.
1.3. So I can write K is equals to N is equals to 1.3 here. Okay, so 0.2 is given. So what we are supposed to do? So all the information I have got. So what we are supposed to do with this?
Find the pressure at state 3.
So you have to find what is pressure at state 3. Okay. So how can I do this? And this is the only thing or anything else is asked?
Work done also you have to find.
So work done from 1 to 2 and work done from 2 to 3. Is it? So both the things we have to find. Okay. Now, so let me find the pressure at state 3, which is this here. You need to find the pressure at state 3. So any idea how to find out this?
We have to use the formula P2 V2 minus P1 V1 by 1 minus N.
Yes, exactly. So you have to use the formula known as PVT conversion equations. Okay, we have to use the formula PVT conversion equations for which process, whether for 1 to 2 or for 2 to 3. Which process should I
2 to,
use?
2 to 3.
2 to 3 I should use. So if I want to use for process 2 to 3, which process is this? So this is
Polytropic.
polytropic process. So for a polytropic process, what is a PVT conversion equation? So if you get confused, just write the basic thing what you have known. So it is P1 by P2, that is equal to V2 by V1 whole to the power of n, that is equal to T1 by T2 whole to the power of n divided by n minus 1. So that is the formula for process 1 to 2. Now I have to get the formula for process 2 to 3. This is for 1 to 2. Okay. So just change up the things, man. So it is P2 by P3, that is equals to V3 by V2 whole to the power of n, that is equals to T2 by T3 whole to the power of n divided by n minus 1. So which two terms am I supposed to consider now? So if I consider these two, that's more than enough, correct? So considering those two, it is P2 divided by P3, that is equals to V3 divided by V2 whole to the power of n. From this, I want the value of what? P3 here. So P3 is equal to P2 divided by V3 by V2 whole to the power of n. So same thing I'll be taking here. P3 is equal to P2 divided by V3 by V2 whole to the power of n. I think I know all of them, just substitute it. It is 5 into 10 to the power of 5 divided by V3 is how much? 0.2 divided by V2 is 0.09. While substituting the formulas, always look into the state table. Okay. N value is how much? 1.3. So give me the value of P3, guys.
One 177.07 into 10 power 3.
Okay, 177 into
0.07 into 10 power 3.
0.07 into 10 to the power of 3. Everyone got the same value? Just check. Fazil.
Yes, sir.
So value of P3 is correct. Given by whom? Karthika is.
Yeah, I'm calculating, sir.
Calculate. That's Namita.
Yes, sir. I got 177.071 into 10 to the past 3.
Okay, you got the same value. Fahad
Yes.
also got the same value. Okay. So let us consider that thing. So can I write it as just 1.7 into 10 to the power of 5? I've just changed the decimal points there. Okay. Next is one thing you have calculated. The first thing is done here. So this particular thing is done. Now for the second one. What is the second one? You need to calculate work done from 1 to 2, work done from 2 to 3. So work done from 1 to 2. First look into the process diagram and say which process is that. So 1 to 2 is an isobaric process. So what is the formula for work done from 1 to 2, which is isobaric? Abhinav? Abhinav.
Hello, yes, sir.
Uh, So what is the formula for
So
the
P into V2 minus V1.
excellent? So it is P into V2 minus V1. So you know what is P? P is the pressure at which the isobaric process takes place, which is 5 into 10 to the power of 5. So 5 into 10 to the power of 5 into V2 value is 0.09 from the state table minus V1 value is 0.03 from the state table. So work done from 1 to 2, which is
30 into
isobaric.
10 power 3.
How much?
30 into 10 power
30.
3.
Okay, can I just write it as 30 kilojoules directly?
Yes.
Okay, so that is work done from 1 to 2. Next, work done. Okay, what page? Next, work done from 2 to 3. First, look into the process and judge which process it is. So from 2 to 3, it is polytropic process with an index 1.3. So work done from 2 to 3 is a polytropic process. So for that, what is the formula? What is the formula? Adarsh. Adarsh.
Yes, sir.
So what's the formula for
P1
process
V1
1, 2 to
minus
3?
P2 V2.
divided by
P1 V1 minus P2 V2 by N1 minus N minus 1.
n minus 1, is it? So now the process is not 1 to 2, but it is 2 to 3. So how am I supposed to write it for 2 to 3? Can I write it as P2 V2 minus P3 V3 divided by n minus 1 for the process 2 to 3? Is that correct, Adarsh?
Yes.
So now substitute the things, guys. I think you know everything. Yes, V2, V2, V1, V. Everything is known. So just substitute and give me the value. So give me the value in kilojoules. So into 10 power 3.
31.95 into 10 power 3. 0.95
0.95. Yeah, okay, kilojoules.
into 10 power 3.
Okay.
Yes.
Just check the values given with the Karthik. So even he has asked the net work done, correct? So net work done is the thing with step live 1 to 2 plus step live 2 to 3. Okay, just add up the things. So it is 30 plus 31.95. So it is around 61.95 kilojoules. Just check the values. If this is correct, this should be correct. Shehzad Abdullah, Sagar.
Okay.
Sir,
So what's the answer from you guys?
work done, I got 32 kilojoules
32 in and around. Okay.
because I took 1.77, so I get 32.
1.77. Fine, fine. No issue. And what about Shehzad?
Thank you.
Same thing. Okay. So that ends the problem. Okay. Everyone taken down along with the explanation, I guess. Shall I move to the next problem? Yeah.
Yes, sir.
Okay.
So just the first page for 2 minutes.
So how is the portion level for other subjects, whether they have completed the first module?
Yes, sir.
So all the subjects have completed the first module?
Not all, sir. One subject completed first module.
Okay, okay, fine. So, okay.
Another 90% is covered first module.
Acha. So here also we have a couple of problems, like around 3 to 4. So this work and heat concepts are very, very vast. They can generate numerous kinds of problems in work and heat. And all are easy. That's a different story, but they can generate various types of problems. So we will solve a couple of problems which are required for our examinations. And I requested you guys way long back to send me the question papers if you have for the subject, because in the library I just found 2 of them. So if you have the question papers of this particular subject, kindly mail me. Okay. Anyone having those? Anyone having the question papers of this subject?
No, sir.
Okay. I've tried online, but very few people. That was not available for your branch. In the library, only 2 I have got. Okay. This problem is really interesting. Take down this. While you are taking down, just try to read the problem. Okay. When you read the problem, try to plot the PV diagram of it. I'm telling you, if you draw a PV diagram of any problem, so your 90% of your work is done. That means it is 100% chance that your problem would be right. So evaluators also will just look into the PV diagram what you have drawn, because if you go right with the PV diagram, all other things are just substitutions of the formulas. That's it. Not a big deal. But if you go wrong with the PV diagram, then your entire problem would be zero. Okay. Abdul Rahman. So just try to draw a PV diagram for this particular problem. And it's a closed cyclic problem from all the previous problems we have solved, non-cyclic ones. So this is a cyclic one. Okay, that means your initial and the final state it will be the same, which gets repeated. Okay, just try. Abdul Rahman, Abhinav.
Yes, sir.
Okay. Next. Adarsh.
Present, sir.
Next. Hamad Reza.
Sir, can you just please read out the problem, sir? Like we can't understand some of the words there.
Yeah, I mean, because my handwriting is really bad, I will just leave the space. Meanwhile, I take the attendance. After that, I'll just dictate it once again, so that if the things which you have got did not understood, you can just write there. Leave the space if you do not understand. Ashanul
Okay.
Mustafa, all this. Akshay, Amit Yeslahari,
Present,
Amrit.
sir.
Okay, Amit Lahari is present. Next is Amrit,
Present, sir.
Anvit, Ashwin, Ashwita,
Present, sir.
Chandan C,
Present, sir.
Benoy, Fahad, What's the problem, man, Fahad? I think you are in a space station. Fahad, okay.
Sir, yes, sir, yes, sir.
Okay, fine. I got you, man. Yeah. Faizan. Okay. Kara. Okay. Gautam. Javel.
Present, sir.
M. Karthik is there. Fazil.
Present, sir.
Sihab.
Placement, sir.
So, how should I get the list of the students who attended the placements today?
I think Lenson sir will help you, sir.
Okay, I will try to contact him. Tausif Ali. Muaz. N. Suraj.
Present, sir.
Nafa. Abdul Rahman.
Present, sir.
Namita.
Present, sir.
Nandesh.
Present, sir.
Nartan, Niharika, Nishchit. Okay, so the problem here is the cylinder contains 1 kg of certain at an initial pressure of 20 bar of a certain gas. You can take it as certain gas. Okay. At an initial pressure of 20 bar, the fluid is allowed to expand reversibly behind a piston according, there are two accordings again, so you can rub the one. Okay. So according to the law, PV whole to the power of 2 is equals to constant. That means it gets expanded using a polytropic process with an index of 2. Okay. Until the volume is doubled. So, until the volume is doubled. The fluid is then cooled reversibly at constant pressure until the piston regains to its original position. Okay. The heat is then supplied reversibly with the piston firmly locked in the position until the pressure rises to its original value of 20 bar. Calculate the net work done by the fluid for an initial volume of 0.05 meter cube. Anyone have tried the PV diagram of this thing? Anyone have tried it? Yes. Namita?
So first, polytropic is followed by the isobaric.
Polytropic is followed by an isobaric, yes. So if you have drawn Karthik, you can just switch on your camera and turn the camera around for the back camera and show us the PV diagram.
No, sir, I have not drawn it.
Okay. Anyone have tried it? Oh, Numan Waitman still have just called 30 people. Still there are many more. Okay, I should take the attendance for. I'll call you, okay? So let us try to draw this. Okay, I think this. So what is the first information given?
Initial pressure is 20 bar and the fluid is allowed to expand reversibly.
Okay.
Following
That
the
means let us state that is the state 1, which is your initial state, okay? Initial state 1, and the pressure of that particular thing is given as 20 bar, so 20 into 10 to the power of 5. So I have extracted the data from the first sentence, okay? Now, secondly, what he says is, contains 1 kg of mass, he says, right? So mass of the gas is given. I should write it. So I'll just write it here. It is mass of the gas is given as 1 kg. Okay. Now, that is your first statement, the data extraction. Now the second statement. The fluid is allowed to expand reversibly behind a piston according to the law PV square is equals to constant until the volume is doubled. Okay, so this is your statement. So the initial pressure is 120 bar. Okay, he says, so this is your 20 bar pressure, right? Which is your state 1 again. So this is the state 1 and this is 20 bar pressure. Okay, now he says, from the state 1, the gas expands reversibly following the law PV square is equals to constant. So which process should I consider it as?
Polytropic.
So PV, polytropic process. So how does a polytropic process look on a PV diagram? It's a curve, is it? So it will just be a curve like this. Okay, until when in the sense, where is your state 2? He says it gets expanded until the volume is doubled. Suppose, okay, so this is your volume, which is V1, okay, and the volume is doubled in the sense, when it becomes the 2 times of its volume, then it will reach the state 2. That means, suppose for in case I assume this as 5, and it will expand up till when? Up till the volume is 10. Okay. Suppose this is a volume 5, and it will expand up till when? Until the volume is doubled. So can I just take this particular aspects like this? Wait a minute. Okay, no problem. So can I just take it as V and this as 2V here? For
Yes,
the
sir.
instance. Okay, understood this particular concept. So this is the polytropic equation, and this is the process by which it is going. Okay, now from here, so that is the data extraction from the second statement. Okay, so here you have an state 2, okay, where the pressure is unknown and the volume. Okay, so here it is V. I can write it as V1. So this is 2, right? So it is 1 here. And for 2, state 2, how much? It is 2V. So I can just write it as 2V here. So this is the complete data extraction. Next, the fluid is then cooled reversibly at constant pressure. So if a certain amount of fluid is cooled, okay, what happens to its volume? Whether the volume will decrease or volume will increase if a fluid is cooled. Yeah,
Increase. Increase.
volume will increase.
Decrease.
Decrease.
Huh? What Karthik?
Volume will remain same, sir.
How come, man? For a gas, so if you remove heat, what happens? Automatically your pressure drops. Pressure drops in the sense there should be decrease in the volume. Okay, yes, they just says all are right. So there would be a decrease in the volume. So he says, see, once again read the statement. The fluid is then cooled reversibly. From this cooled reversibly, I can judge that my next process, which is for the state 3, is not this way, which indicates it as a volume increase. So it is in this way I can judge it as, right? Because it is cooling. Volume should decrease. Okay. Until where it is cooled, again the statement is given constant pressure until the piston regains its original position. What was its original position? Original position was state 1. So your gas will get cooled isobarically like this until when? Until the piston regains to its original position. Original position was state 1. Any doubts here? So this is your state 3. Yeah? Any doubts?
No, sir.
Next, state 3. For state 3, for again, so he says piston regains to its original position. Fine. So, what is the volume at state 3 then? Again, V? Yes? The volume at state 3 is again V. So, can I just write it as V again here? Now, coming next is, where is that? This one. Heat is then supplied reversibly with The piston firmly locked in the position. Okay, with the piston firmly locked in the position, that means if your piston doesn't move, the volume will not increase or decrease. That means which process? If volume does not increase, it is which process?
Isochoric.
Isochoric process. So isochoric process that we have understood. That means definitely it is a vertical line which either goes this way or it goes this way. Now we have to decide whether it goes upward or it goes downward like this. Okay, that we
Reversible.
have to decide. Yes, it is a reversible process. Now, how do we decide it is upward or downward in the sense? When you heat up a gas, what happens to its pressure? When you heat a gas, what happens to its pressure? Take an example of a pressure cooker. You're heating the fluid inside the pressure cooker. What happens to its pressure? Yeah?
Increase.
Pressure will increase, right? So that's why, should I go towards the top to meet the state 1 or should I go towards bottom? Which is right?
Towards top.
Towards top, is it? So because as soon as you give the temperature, your pressure gets increased. So again, it forms your cyclic process here. 1 to 2, yes, 2 to 3, again back to 3 to 1. That means your initial and final state is 1, which means it is a cyclic process. Okay? Now, anything else information is given rises to the original value of a 20 bar, he says. No issue. Okay. Now, calculate the net work done by the fluid for an initial volume of 0.05 meter cube. Where is the initial volume? Initial volume in the sense state 1, state 2, or state 3? Which one? Initial volume, he says. Initial volume is 0.05 meter cube, he says. So which volume should I consider it as? Whether it is...
State 1, V.
Okay, state 1. Very good, sir. So it is 0.05 meter cube. So if it is 0.05 meter cube in the state 1, it's double in the state 2. That means it is 0.10. Can I just write it directly as 0.1? Yeah?
Yes.
So if it is 0.05, again in the state 3 also it is 0.05. Okay. So here completes your complete data extraction from the problem. Okay. Yes. So what we are supposed to find here?
Work done,
What we are supposed to find?
at each processor.
So we are supposed to find work done and the net work
Yes.
done. So W net is equal to work done from 1 to 2 plus work done from 2 to 3 plus work done from 3 to 1. Calculate individually, that is just work done from 1 to 2 first. Okay. Calculate the value. Next, work done from 2 to 3, you calculate the value. Work done from 3 to 1, you calculate the value. And club all the things to get your final answer. So how many of you say, sir, from now on, I can carry on the problem and do the problem? There is no issue solving this. How many of you say, no, sir, I am not getting the things right now. I should still understand the concepts. Yes, I need answers. Can solve. Okay. What about others? I did not understand the concept, okay? Did not get it. I can. Okay. 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 Fine. So NAFA and whoever it is NAFA and Sujay.
Is it
Yes.
500 kilo?
I don't have answers, Karthik. I will just check.
P2, sir, P2.
I don't have answers as of now. I'll just check with the
Okay, fine.
textbook. Okay. Those who say that I can't solve one. First, NAFA and whoever it is, Sujay and all. So just listen here. Okay. So there are basically 5 processes. Okay. So this particular thing. So for these 5 processes, what are the different values are constant? Suppose for isobaric, which one is constant? For isochoric, which one is constant? And what is the value of K, which is used to represent in a PV diagram? And how these processes are represented or visualized on a PV diagram? And what are the different work done expressions of all these PV diagrams? And what are the PVT conversion equations of all these PV diagrams? If you learn it, then the concepts are very, very easy. The only thing you have to learn for this whole subject, not only for the module 1, for the whole thing, is these things which I have just stated. Okay, kindly read those and try to solve. You will definitely get that. If you don't get it, I will explain it once again. Okay, once the time permitted. Okay. Yes. So this problem I leave it to you guys. Okay. Just solve this. By the next class, I need answers from everyone. Okay. So this ends your different types of problems, which is process-oriented work problems. So all these are process-oriented work. So there is some of the process in it. There are some problems which are not process-oriented, but they are entirely work-oriented. So these problems should be just like your mechanics problems, where you use the formula such as 2 pi nt by 60, a spring work, pressure, and all those things in your second. It will be just like your second PU problems, which have a basics of mechanics. So such kind of problems we'll be doing in the next class and winding up this particular module. Okay. So first I will take the attendance, then you can leave the class. Okay. Nitin George.
Present, sir.
Next is Omkar. It's not there. Prathan.
Present, sir.
Next is Pratish. Prajit.
Present, sir.
Rakshan.
Present, sir.
Ramdas. 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 Not there. Ranjit. Sabit.
Present, sir.
Sagar.
Present, sir.
Shahzad.
Present, sir.
Shashank. Shashank. Shetty Sujay.
Present, sir.
Shetty Tejas. Okay. Sujay
Present, sir.
just. Okay, Tejas Shetty, fine. Sujay and Nafa, you just read the formulas once again. Okay. Get your concepts right first. After that, I'll be explaining you once again. Okay. Shravan Shetty Tejas is done. Shravan Kumar. Okay. Sriraj. Saurabha. Sumant. Varun. Vigneshwara. Amit Sungarli.
Yes, sir.
Okay. Nilesh.
Sir, his aptitude class is there. Aptitude test.
Okay. Prajwal. Prajwal. Sandesh. Rachan. Rohan, Varun. Rohan is there. Okay. Varun, Adarsh P.
Yes, sir.
Next is Sampreet. And Muhammad Amin. And Manasati. Okay. So try this problem, guys. By the next class, give me the answers of it. Okay. Take care. Bye. Meet you in the next class.